One problem that you may be facing when creating a custom shader like my water shader here is that if I scale the 3D model, the shader output will be scaled as well, and that's not what I want. In this video, I will show you how to tweak the shader graph so when we scale our 3D model, the scale of the output of our shader stays the same. Hi, I'm Peter and welcome to Sunny Valley Studio Tutorials. Here is the water shader that I am currently using. If you are not interested how it works, you can skip to the next chapter of this video. Basically what we use is Voronoi noise generated based on the UV coordinates, and we use also the time, we add to the time 4 and we apply it to the angle offset to make this Voronoi noise move. Otherwise, if we use value 0, we are going to get this grid-like pattern. That's why we need to add 4 to this time initial value, and if we increase it, you can see that this starts to move. That's why we apply the time here, and it outputs the new UV coordinates. We are going to use power because basically what we have in the Voronoi pattern is black dots moving about. So if we apply power node to it, so we raise the values to some power, and those values are from 0 to 1. The values that are in between 0 and 1 will get smaller if the power is larger than 1. That's why we have enlarged those black areas. And last thing that I did was applied the color to those black and white areas. Since we have values 0 and 1 here, for values 0 I have applied this blue color, while for values 1, so those seams in between those black circles, I have applied this bluish white color, so the output is like this, and this outputs to the base color of the fragment shader. Now, as you can see, we are not including anywhere the scale of an object in the calculation of our shader. First, we need to understand that the UV coordinates define the color that is applied onto our 3D model. So if you want to tweak the color, or if you want to tweak the pattern that is outputted onto the surface of our mesh, we need to play around with UVs. Now, this is an extract about UV coordinates from the Unity Shader Bible by Jetali. I strongly recommend it. Check it out. The link will be in the description. Chapter 1 is free to access. And basically what we need to see is the values of UV coordinates are vector 2. And they start at the bottom left corner with values 0, 0 and end at the top right corner with values 1 and 1. And we need to affect those to ensure that our shader scales correctly. So the problem that we are facing is that despite the scale of those two planes is different, now we are using planes, so we are modifying the x and z value, the UV coordinates stay the same. So in the scale, with the scale 1, 1, 1, the bottom left corner is 0, 0 and the top right corner is 1, 1, and with the new scale it is the same. So basically our pattern is stretched because of this, because we do not take into account the scale and we do not modify our UV values. What we need to do is use tiling and offset node. So Unity provides us with this node that takes in UV and allows us to define tiling of those UV values, and it outputs also the UV values, so the new UV values with the tiling applied onto those. And we can of course apply offset, but we are only interested in tiling. So if we go back to our shader, what we can do is press spacebar or right click and create node, and let's type tiling, and we will find tiling and offset node. And what we will be able to do is set the tiling to something bigger, so let's increase it. And if we set it, for example, to 5 and 5, you will see that this part is now bigger. Basically, what we have done using this tiling is we have increased the range of values for our UV coordinates. So we still start from 0.00, but in the top right corner we now have 0.55. This is why this yellow area is increased, because those values have increased above value 1, which was the endpoint in our UV values without this tiling. So back to our graph, what we want to do now is, instead of this static value, we want to set here the scale of our object. To do this, we need to again create a new node, so spacebar or right click and create a node, and let's type object. So object node allows us to get the position and the scale in the world space of our object. But if we select the scale and we type split, you will see that we have three values. This is RGB. In our case, this will be X, Y, and Z. So those are the different axes of our scale values, our scale vector. Now, in my case, I am using plane, which is scaled on X and on Z. We not include Y because it does nothing in our setup. So this is what we need to include. Now, in our tiling and offset, we can only apply vector 2 here because we have 2 here and we have only X and Y value. So what we need to do, in my case, when I'm using plane, I need to combine X. I'm going to type vector 2. I will drag R values to the X spot and B value, so this is Z value, to the Y spot, and now I can apply it to the tiling. And as you can see, now it is back at the default values because we need to read the scale from our model. So basically this way we are going to modify the UV coordinate range to be the same as our scale that we have set for our 3D model. All we need to do is output this value to whichever node is using those UV coordinates. In my case, this is this Voronoi noise. I'm going to save this shader. I'm going to go back to Unity. And now, if I scale my shader, you will see that now it is scaling and it is taking into account this scale. Now, another thing that you might want to do is you might want to also include some sort of a vector to default tiling that you might want to set through the material. So you might want to drag this vector 2. Let's set its value in the graph inspector. The default value will be 1 and 1. And what we can do is we can multiply the output of our scale, multiply, by this value of the tiling that we want to set by default, because maybe we want those output of the Voronoi to be smaller, so we want to set it as the tiling of our UV. So if I set now the tiling to be 2 and 2, as you can see, we have made our Voronoi pattern smaller. So this is what you might want to do, and I'm going to save this shader, go back. So now I can select my shader material, and in the surface input, I will be able to define the tiling that I want to apply to increase or decrease the number of those shapes outputted by the shader. And it will still work if I set it to be 3 and 3, and if I scale it, it will scale properly as we have intended. Great! I hope that you have enjoyed this video. If you did, leave a like, let me know what you think down in the comment section. It really helps me a lot. See you in the next tutorial. Take care.